Alright, determine the type of distribution and best measure of center and spread of each data set. Round to the nearest hundredth if necessary. I'm sure I'll do this in a calculator tomorrow. We'll see. There needs to be a comma there, not a period. I need to fix that. Oh wait, that is 14. I'm an idiot. It's number 14. Tired, been a long day. It was ACT day. Just did some tutoring. I've got a few minutes before I have to head home, so this is for you. It's obviously not for me because I'm ready to go home. And it's honestly quite boring just pushing buttons in a calculator. But it's not hard. So there's that. 20, 23, 22, 21, 21, 18, 17, 17, 14, 12, 6, 3. Alright, so if you weren't paying attention in class, I'm going to quit out of this. I'm going to go to stat plots. I'm going to turn them on. And I'm going to choose histogram. Right there. Enter. Then I'm going to hit zoom. I'm going to hit the up arrow because it's quicker than down. I don't know why, but anyway, zoom stat, zoom 9 is what you do. And it's going to draw me a nice little histogram. And obviously I still have something in y equals. Let me clear that out. Alright, back to what my graph looked like. So let me take a little snip of that and then I'll draw on it. And I'm supposed to describe that. It's not quite normal, but in some degree it is a little bit normal. I would be more inclined to call that fairly normal. Now, since it's fairly normal, my measure of center is going to be the mean, x bar, and my spread is the standard deviation, sigma subscript x, because it's fairly normal. So anyways, quit out of this, stat, calc, one variable statistics, and calculate. So my mean is 16.833, which could be expressed as 5.6 if you want to do that. And my standard deviation is that guy. Now I'm too tired to remember these numbers. So I'm just going to do this. And again, the ones I'm after are the mean and the standard deviation. Those two right there. That's what I want. Boy, that's blurry. Must be something that I shrunk and enlarged. A ball takes 5.2 seconds to roll from the top of a ramp to the bottom. The ball's initial speed is 0 meters per second, and its speed at the bottom of the ramp is 1.4 meters per second. So the idea here is that as a ball rolls down, it gets faster. Now, there's some things in here that are just some dead giveaway. This says speed meters. Speed is not measured in meters. It's not. It's measured in meters per second. It'd be meters per second. So anything that says something stupid like that is gone. Oh wow, that's really all I needed to know, wasn't it? This one doesn't make sense because the bottom should be time. I guess there were two choices, all right? So there's your two choices. They mention how you measure speed. Now, in a perfect world here, speed, because of this setup, the more you roll downhill, the faster and faster you go. Speed depends on the time rolling. Speed depends on time. Time is the independent variable, which we passionately call x. The x-axis needs to be time. There are so many kids that miss questions like this because they don't understand which axis is the independent axis and which axis is the dependent axis. The correct answer is A all day long. They've got this one backwards. They're saying that time depends, that's what they're saying. They're saying time depends on speed, which is not true. All right, the volume of a cylinder with length h and radius r is given by this simple formula. Volume is pi r squared h. An unsharpened pencil, which has a length of 17.5 centimeters and a radius of 5 milliliters. Here's where they're trying to get you. What they are doing is they're hoping you're thinking volume is pi 5 squared times 17.5. I guarantee you that's an answer choice. Let's see if it is. Pi, if I can work it, pi 5 squared 17.5. Yeah, this is a very good distractor. That's what it is. It's a very good wrong answer. I don't have any way of pulling up your reference sheet, but your reference sheet has the conversions and stuff. It does. Let's see if I can bring it up real quick over here. Let's see, TN EOC reference sheet. There we go. In a perfect world, you'd know this kind of stuff by heart, but you don't. So, anyways, that's what I needed. So I noticed they talk about 1 centimeter being 10 millimeters. You see that? 1 centimeter is a millimeter. And how do they want their answer? They want their answer in cubic centimeters. See where it says cubic centimeters right there? So if 1 centimeter is 10 millimeters, 5 millimeters is going to be a half of a centimeter, 0.5 cm. Now the reason I'm sticking with centimeters is because they want the volume in cubic centimeters. So now when I type out my little formula, it's going to be that pi symbol. Hope that'd be a Greek letter. And it's never going to let me type it. You guys can see as well as I can. I do that I'm touching pi. There we go. And where we see r, we're going to be 0.5. And then where we see the height, we're going to be 17.5. And that's what we're going to push buttons on. So again, it's just a good distractor they're doing here. Some of you guys don't know how to use your calculators, and it shows. I'm not retyping all that. I highlighted the old one, pressed enter. I'm inserting a decimal. Bam. 13.74. Easy peasy, Japanesey. Alright, a circle has a center at 6,2. A point at 12,1575 is on the circle. What is the radius of the circle rounded to the nearest whole unit? Now, I don't know if it's worth doing, but I think for most people, if you draw, you'll start thinking about what's going on. A lot of kids won't draw. That's why they kind of stink at the subject. Here's the center of your circle. It's at 6.2. And it's a circle. I'm just going to draw a circle. I know that this point 12, 15.75 is on the circle, so I'm just going to pick something to the right, and it's 12, 15.75. The most obvious thing to do here would be to use distance formula. The distance formula, the square root of x minus x squared plus y minus y squared. So this would be 12 minus 6 all squared plus 15.75 minus 2 all squared. And again, we'll just pretend that we're dumb, okay? We'll pretend we can't do any of this in our heads. We'll pretend we don't know what 12 minus 6 is. Because some of y'all would miss that. The problem is the same kids who would miss that would not know the distance formula. It's the distance formula, man. It's a middle school standard. It's taught in 8th grade. Anyways, it's about 15. And I think they want the nearest whole unit. The radius is about 15 units, whatever the units are. And I think this is the last one. It is. Determine whether each measurement is a statistic or a parameter. Statistics deal with samples. Parameters deal with population. I was supposed to say population, but I ran out of room. So in a randomly selected group of first grade students, it was a selected group. That is a sample. That is a statistic. The median age of teachers at a school is 39 years. Now, the way this is wording, it's talking about all teachers at the school. That is a parameter in regards to the school. In a phone survey, 89% of people who responded, this is definitely a sample. That is a statistic. And that is the end of your 11.3 homework. All right? So I'm done with that.